record. Okay, so it is May 6th, and we're going to look at another database, another MySQL database, using another venue, using that W3 Schools that I showed you before. Um, the uh, the thing you want to click on is this Try It Yourself button, and that will bring up a new tab, which, oh, I already have one. That will bring up a new tab, um, which is a fully functional. See this SQL statement up here. This is a fully functional SQL prompt. It 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 will interact with MySQL using this database over here on the right. Let me pull that out here. This database on the right is the Northwind database that I've mentioned a couple of times, the one you have access to in SQL Workbench, MySQL Workbench. But it's a stripped down version. There are a few like lookup tables that are not in it, that we have in our instance, and in the official version, I guess you'd call it, like that comes with Access and SQL Server. So it just pulls those, but it has the primary relationships that you would be looking for. Um, it has like a customer database. We'll show you that. Okay. And so the primary key of the customers table is customer ID. They use, oh, good grief. What do y'all remind me? What do you call it when you don't use underscores and you use capital letter of the first letter in each word in the variable name? Um,
The camel case?
Camel case, that's what it's called. They use camel case as their naming convention, and remember, it's case sensitive when you're selecting these database objects. So you'll want to remember that. But they use, so you won't see any underscores in here. That's one good way to remember it. But here's your customer table. You got 91 customers. Customer name is actually a company. Um, the contact name and address and city, postal code, and country. So that's a base table that is used to track. This is like the Northwind database is a shipping company, or a import export company, I think is what they describe it as. So then you got customers place orders. So you've got that relationship there. So yeah, this customer ID in the orders table is the customer that ordered it, that placed the order in the customers table. I've got an ERD for this. I'll post, but it's not it's not accurate. That's what I was, remember, Laura, when we were talking about this, you didn't find an ERD on W3 Schools, did you? I looked and looked, and it's just similar enough to make you be able to use an ERD from another There's multiple versions of perversions of Northwind database out there that use different field numbers, or I'm sorry, different column names, and it's just different enough that you don't. So I would have to like make my own for this thing, which I guess I'll wind up doing next time, if I'm going to have installation weirdness with things like SQL Workbench and SQL Designer. So yeah, so you got orders. Every order has one record for the order itself, but then the order details um, will tell you just real simple stuff. The product in that order and the quantity. The products table is another good base table. It tells you the name of the product, who supplies it, And then you've got a relationship here to category. That's a foreign key. Supplier ID is a foreign key. That's one good thing about this database. Every time you see this camel case something ID, you know that that is a foreign key. It's a primary key in another table, and the way they do the naming convention, you know that this is a foreign key in the supplier table, and that there will be an ID field in supplier that looks like this that is the primary key in supplier. So, for example, we have a Chang. I don't know what a product. I don't know what a Chang is, but we've got product ID 2 is a Chang, and it is supplied by supplier 1. So if we go over to and click on suppliers, we have 29 suppliers. So let's go look at who supplier 2 is. New Orleans Cajun Delights supplies the Chang. So you just got to ask yourself, where do you get your Chang from? Well, I get mine from New Orleans Cajun Delights. So yeah, if you click on the table name, it automatically executes a what were we on? Products? Yeah, we were on products. It automatically executes a select star from that table. Okay, now that'll get you the column names, you know, select star is all the column names in a table. But if you want to see the data types, which matters, the data type of a column matters in how you treat it. That you'll see that particularly in one of the exercise questions today. If you want to see the structure of that table, you say describe. Remember, describe products, and then run it, and you'll get um, the information about the table as you would on an ERD. This tells you that the product ID is the primary key, which we're talking about from the previous discussion. So whether or not it allows nulls, that would be the little uh, fork on your ERD. Of course, the primary key can never be null. And here is your data types. Product name is up to 255 characters. You got a couple of integer types here, but then your price is a floating point or number that has decimal places. So that's the describe statement. Remember? Okay, so and I'm going to go back and regroup on just a few things on single table queries. Um, I'm not bumping up on a break, am I? Nope, 5 more minutes. So remember some. So this is select everything from products. So I want to go back over single table query fundamentals just real quick before we go on break. So select star is selecting all the columns. If you want to see everything in the table, select star from that table. If you want to see one column, select unit from products, run it, and you only get that. If you want to see, let's see, let's select star from products again, get everything. So if you want to see, say, product name from a certain supplier, all the products from a certain supplier. So you'd select product name, and I always like the from on the next line. It just looks weird being on the same line. Select product name from products, and then you got your where clause. Remember, where supplier ID, and it's an integer, so we can say equal. And I think there are 29 suppliers. So let's say supplier 8. So we get 4 products coming from supplier number 8. So that's the thing. I'm trying to stay on keeping on um, single table queries. So, okay, so now we got everything from supplier 8. Let's try a different one, see if we can get some more. No, some more. Come on. Well, good grief. Okay, so what I'm trying to do is show you the reason that it's good to have the order by clause. Okay, so after your where, you will say if you want to sort your output, order by, uh, and you can order by what you're looking at, or you can order them by something else that you're not displaying. You don't have to display the sort field, but this is your quintessential textbook uh, select query. Just selecting one column. So then you see it resorted them. It's okay. Did not say. So let's say select product name. Go back to products. Okay, so you've got this category ID, which is in our categories table. So we have 8 category IDs, but you don't always know that you're using all of the values in a lookup table like this, right? We may have category IDs that we created, and perhaps over the years we just stopped carrying seaweed and fish because we just can't sell seaweed and fish. So if you want to see um, what is being used in a table, you would say select uh, distinct category ID. We don't need the star from products. Let's run that. And they're out of order. So that's kind of, but there are 8. So it looks like we're using all of our categories, but I want to, because I'm OCD, I want to sort that order by category ID and run that. So then it resorts it, see? So let's go back to products, and we can select more than one column, and only what comes after select will be displayed. That's an important thing to remember, because sometimes you'll use tables to go look up related information that are not displayed, and it can get a little confusing. So select product ID and unit from products. So you can select more than one column, or you limit the number of columns. And then remember we had wildcards, right? So it looks like, say you see how we got things in glasses and bottles. Um, there's a whole bunch of different units. This is, what it comes in. It comes in a case of 24, or you can only order a package of 6. That's what unit of issue is here. So let's say we want to find everything that comes in a bag. Looking down through it, you could have 5,000 rows. So let's look for all the products that come in a bag. Product ID and unit from products, where unit, and remember it's like when you're using wildcards. And it seems like this will take either a single or double quote. Like I said, I am still trying to really come down to the rules of when you have to use one or the other with MySQL. Where unit like, so we want anything. So %sign stands for any character, bag, and then any character afterward. So that's how you would find any product ID and unit that has. I hopefully you guys are typing along, following along here. Everybody's got access to this, I assume. Um, it's not safe for me to assume anything, but hopefully you would holler if you're not able to follow along. So you run that and see what did I. There you go. 50 bags of 30 sausages. Okay. Product ID 29. Okay, so that's getting to be kind of the gist of where we are with single table queries. I don't know that I gave you anything in this exercise um, that that you need something extra. You need more than this. So we're going to go on break, and then everybody that's on here today, I need you to turn in by what is it 9:18 by 10. Take a crack at these single table queries, and let me show you. Go home. In the classroom, in our Canvas classroom, go down to the relational databases SQL. And here is an assignment called W3 Schools Single Table Queries. And that's a 5. You're only selecting from one table. You're doing a little bit of where and a little bit of this and that. There's one in there that uses a date that I'm curious to see who can either do it from memory. I had to look it up. I had to Google how to handle date uh, date math to like see who was see a product that was manufactured after a certain date. There's a format for the date field that you put in single quotes. So I'm not going to give you any more hints than that. But it's a easy Google to compare dates or date types in MySQL. So between now and 10, if you would knock that out, and we'll come back at 10 and see where everybody's at. Do some screen sharing, put some folks in the hot seat, as it were, and then I've got a little bit more SQL I want to cover, and it'll be using MySQL Workbench, but I'll come up with some exercises over the weekend that use this W3 Schools database to do multiple table queries. Where we're doing the joins and grabbing related data, and like subqueries, which I'll go over today. So there you go, guys. When you click on this single table queries, can you see the Word document that's associated with it? Anybody click on it in the classroom?
Yes, it's in there.
It's in there. It's in there. Okay. Yeah, work on that between now and 10, and I'll see you guys at 10. If you need me, text me. I'll have my phone on me, but I may not be sitting here with my headphones on the whole time. Okie doke. See you back here at 10.
That were, that made sense for the database I was connected to, but I think I only got 1 and 2 actually done. Of course, there's no Germany customers in the North Winds that I had, but the select statement's still there.
Okay. So let's pick on Thomas. If you would. Thomas, share your screen. Let's show us number 1.
Says someone else is sharing.
Whoop, is it me? It is. Go ahead.
Here. All right. You want to just start at number 1?
Sure.
Okay.
Yeah, that was the unique cities.
Yeah, I think there's probably better ways to do mine, but I managed to get results from all of them. So
Okay. So select distinct city. Roger that. And from customers, correct? That's the only table we're dealing with. So um what was the problem with um customer ID? Why did that show up in your
let's see. Let me look at the document and see if I can. Figure out what I was thinking.
yeah, sometimes extra stuff winds up when you're getting errors. That's why
Let's
I
see.
want to see if you were having trouble.
You know, I don't know why I put that in there.
Okay. Fair enough. Get rid of it.
Yeah.
Get rid of your where clause
Okay. Let's see. Completely?
completely. And then run it. Now, I got something different. This is troubling me. I thought I got 77 cities. 77 unique cities. You can continue sharing, but I gotta figure out what happened here. Select distinct city from customers order by city. Semicolon run. Whoop. Gotta get the case right. I put everything in lowercase because I was rushing. Gotta spell distinct correctly. No, 69. Okay. Well, all right. I thought I got 77 this morning, but it must have been just a little too early. Okay, so yeah, you don't need a where clause there. You're just selecting the unique values in a given field. So that's all you need for that one. And then order by, yeah. And then order by city. Okay. Go ahead and kill screen sharing, Thomas, and we'll pick on somebody else. Okay, how about Chase? You want to grab number 2?
Sure. Hold on. How do I? Never shared screen. How do I do it?
At the bottom of the,
Okay.
you got to move your mouse down to the bottom of the Zoom screen
Okay.
and share. You can do a tab or your whole screen.
Hmm. I think it's going to be a whole process, Don. I've got to go into system preferences and a lot of other stuff.
Should I move on?
I did solve it. I did solve it.
Well, just tell us what your
Okay,
statement was.
I did select customer name, comma, country from customers, where country equals single quote Germany, close single quote, and then semicolon. And it
Okay.
came back with, I think 11. Let's see.
Is that what everybody got? Sounds right.
I do it? Okay.
Yeah. Yeah, so it's just customer names, the only field you need, if that's what they're asking, if that's what
yeah, I got 11 results, all from Germany.
all very German sounding. Okay.
Yep.
And
I got it.
yeah, and I used single and double quotes. It didn't seem to mind. It worked for either. There are times, it seems like it's when you're passing a string literal inside of a function is when it's when it wants single quotes. But like I said, I'm still working on memorizing that. Okay. So number 3, this is where I had to do some Googling to figure out the date format. You can do date math. There are in that W3 schools tutorial, you see all kinds of functions that'll tell you like the number of days between calendar days, like the folks from GlaxoSmithKline are looking for how many days it's been that um, a vulnerability's been open or a write-up has been open, those sorts of things. You know, dates since somebody accessed your website. I mean, there's all kinds of different date math. So number 3, how about you, Gabe?
So for number 3, I think I did it wrong because I got this 1960 in there. That's what I got.
That, oh yeah, greater than or equal. Yeah, that interesting that worked. That's cool because the full format for a date field for anybody that struggled with this one. But your 1960, that no, I should have said January 1st. I got you. Yeah, I got you, Gabe. I should have said what I meant was January 1st, 1960. So you know what I mean? Born in 1960 or greater. So that's what I got. But what I wanted to show everybody is, Gabe, go up into your 1960 there, into your query and type dash 01 dash 01, which is the after the 1960. Yeah, there you go. Dash 01 dash 01, and then hit run SQL.
Yeah, it came back with the same thing.
Oh, there you go. So that's the format to do. That's the default. It's y dash mm-dd. So if you wanted to eliminate the youngsters, you could say greater than, change your 1960 to 1963, and your month to say February 02. So this is everybody born after February 1st, and it peels off the older folks. So that's how you do uh, uh, date math. And you could do, while I got you on there, Gabe, go to the end of your query. Interesting that it's not making you put a semicolon. I guess it.
Yeah, it didn't make me on one of them. I did.
I haven't even tried that. So hit enter and get a. We're gonna do an and birth date in camel case there. Just like, yeah. Is say less than say 19, is less than quote 1966, say dash 01 dash 01. So this is anybody born uh whoop, there you go, and close quote. Let's see. I think I wanted to do a compound where clause here. I think you're going to need a parentheses around each condition. So put an open paren in front of your first birth date. No, the word birth date, or the column name. Yeah. So a lot of times you want to, and Laura, and you need around both. So there you go, a closed paren there, and you need an open paren in front of the other birth date. See if that fixes it. Well, Laura and Aaron are both whizzes on.
When I use a BigQuery, like it will not accept dates with double quotes. Like
Yeah, try that. Try single
Yeah.
quotes around your dates, Gabe. Do you think the parentheses are superfluous, Laura?
I wouldn't think you would need to use them, but I'm not a whiz.
And birthday is less than or equal to 1966. I don't know why that doesn't work. It looks like it's recognizing. Go ahead.
I would say don't put the is.
Oh,
Yeah.
I didn't even see that. There you go. Good eye. Was that Laura? Was that you?
Yeah.
Good eye. There you go. So you can do, compound where clauses. You know what I mean? You could have lots of conditions and all you want. You could grab people that are born between a certain window and their hair color is red or whatever. I mean, you can have multiple conditions in your where clause, pulling out those columns. Okay, so that was number 3. And then the next one, I wanted you to remember wildcards. So let's go to Chase. Are you online now, or do we still need to skip you?
I didn't get to that one.
Okay. Damon, are you back? Are you booted up and back?
It looks like he's only connected with his phone.
Looks that way.
And I
Okay.
just uploaded mine.
Okay, Chaz. Why don't you tackle number 4, Chaz? If you can't get all the way there, we'll help you.
Should I share my screen?
Yes.
All right. Can you see my screen here?
I can. I'm in your Word document.
Okay. Do you want to see it in the W3 schools?
Yeah, go ahead and cut and paste that and run it. Okay. So we have two loggers. So we're only working with the products table. And the only thing I asked you to display was product names. So remember the percent sign? Yeah, we went over this earlier. The percent sign is anything or nothing. So this we use the like operator. I was not thinking. I was rushing through, and I was using in for a minute, and I was like, why isn't this working? So you just got to remember, you don't use the equal, you don't use the like, or in, you use like whenever you're using wildcards. So if you take off the leading percent sign and see what happens, run it. No, you get nothing because nothing starts with logger. So that's the important thing to remember about your wildcards. All right. Any questions on that one? Or anything that we've done? And we doing okay? Got one more, and then we'll learn a little bit more SQL. And like I said, I'll do a little bit of a refresher on Tuesday of multi-table queries, joining tables together to get kind of summary data or related data. Um, and then today we're going to talk about a couple of different subqueries. I don't want to get too far into joins. I'm not super confident at them, but I got a buddy I'm trying to talk to coming in the class next week to wrap up our SQL. Okay, so for number 5, let's go. Andra, have you gone?
No, but I did not get there.
So you haven't even tried it?
No.
Well, let's try it.
Oh boy.
Oh boy.
Okay.
Now this one is really more of a pain because you're having to go back to the orders table and look at the structure of it. But okay, so we are retrieving the order ID and order date from the orders table for all orders being shipped by shipper ID 2 and handled by employee ID 4. So if we're going to retrieve order ID and order date from the orders table, how do you start out?
Would you still do select?
You still do?
Okay. Order ID, comma, order date.
Yep. And make sure all it's case sensitive. So make sure everything. It's order and then capital ID. No space. If you put the space in there, it thinks it's two different things. Order date. Okay. Then yeah, good job. I always put the from on the next. Well, if you can put from and select in all capital letters, but the table names and column names are case sensitive. So yep, there you go. And then hit run SQL. So that's where you get every order ID and its date. 196 orders in our order table. So, but we only want to look at stuff being shipped by shipper ID 2 and handled by employee ID 4. So let's do that first one. So how would you limit this down so that the shipper ID was 2?
Something like where shipper ID equals 2.
There you go. So go add that
By
to
using
your, just add it, yeah, put
where
it on the next
statement.
line. Yep, where. And that breaks it down to 74 records. That's less, right?
Mhm.
I can't remember the other number. Okay, so now we want to add an additional constraint to only look at the orders that are being handled by employee number 4.
Do I do another where statement?
You only do one. You only do one select. Well, that's not necessarily true. In a single query, you only have one select, one from, one where.
Mm.
But you want to add an and where shipper ID equals to and. Yeah, you can do it on the same
Employee
line.
ID equals 4.
And employee ID equals 4. It's freaking me out that you don't need this. So now we bring that down to 17 records. So there's your 2 yeah, so we did not need those parens on that date math thing. It was the is that I didn't even notice that was causing the problem. Good eye, Laura. Okay, so that's 5. These are single table queries. There's no join. Thanks, Gabe. Andra, sorry. There's no joining. There's no foreign key, primary key, relationships, anything like that to work with. This is just pulling flat data out of a table that you might then be able to pull into Excel and do a chart on, or pull it into a pivot table. So I want to cover a couple of things with a couple of features of SQL. What have we got? 1036. Yeah, I think I'll go through this stuff and then let you guys work on that W3 Schools site. There's all kind. I mean, that is a fantastic site, and it's absolutely what we're trying to do as SQL Workbench without all the technical glitches. Okay, so the next thing that we were getting to is in the classroom. Share screen. Share screen. You have a couple of presentations here that I need to get to. Subqueries and outer and self joins, which I'll go through it. I'm pretty sure I double checked all the query syntax, but outer and self joins are, I'm going to call that advanced SQL. It's the way of getting related data from another table, but it's the union of the data is different than our nice little inner join that we've been doing, the default simple inner join. But let's look at subqueries. We've looked at using column stuff in a where clause, but this will allow us to let's see, stop share. Where am I at? Stop that share. Pull up. subqueries. Here we go. Or nested queries. And do I have Workbench up? I do not. So I'm going to have to demo these in Workbench because they're all written in the in my Northwoods teaching database. But I will come up with some exercises for you guys to practice these things using W3 Schools. Oh, one other thing I want to show you. I'm sharing my whole screen, right? You seen SQL Workbench? Yes?
I don't think you're sharing screen.
I'm not sharing.
No.
I'm not sharing. Ah, there it is. Screen share, whole screen. Another thing that you might find useful, and you might find a little confusing, but you might find a little bit useful, is I uploaded to the classroom. It's Northwind database query exercises. Now, that is the Northwind database. It uses most of the same tables and everything. Like I said, it's what we have in W3 Schools is a subset that leaves off some other complex relationships that we don't really care about, and it eliminates a lot of the fields to make the database more compact, because there's who knows how many thousands of people working on that website at any one point in time. But this Northwind database query exercises thing has an entity relationship diagram that shows you how the database is laid out, but it's not exactly right. So you've got to kind of take it with a grain of salt. And it's also got some sample problem queries that you could try and accomplish using the W3 Schools Northwind. So I wanted to put that out there because it's close. It's better than nothing, but it does require you to, like I said, the column names are different frequently, but it's pretty good. It's a pretty good resource. All right, back to subqueries, nested queries. So I'm going to try and fit all of this on my 27-inch monitor. And bring up Workbench and PowerPoint. Okay, and we are in the Northwoods database. All right, can everybody see? The PowerPoint and Workbench?
Yes.
Cool.
Yeah.
All right, cool. All right, so a subquery or a nested query is kind of like, remember when we were doing Python and I put like an if then else nested within a loop? Or I nested ifs within ifs. You can have, multiple layers of these things. Well, SQL understands the same basic concept. So you can have, you can nest a query within a query, but generally speaking, that nested query is going to be used in a where clause. So you can use it as a constraint for the parent query. If you wanted to select everything from a table that was greater than the average of everything in that table, you would need two queries. And I'll get into some examples of this. The main query is, select shipping weight, say, from shipping table where shipping weight is greater than, and then you would select the average of shipping weight from shipping table. And I'll show you this. So hopefully this won't be too confusing, and we'll do a few hands on Tuesday I don't really have exercises ready for this one. I ran out of time. Okay, so nested and subquery, they mean the same thing, and I will frequently confuse the wording or use them both. There you go. In red, the value returned by the subquery specifies a search condition for the main query. That's where you see these nested subqueries. So an example, this retrieves, and remember, we're back in our Northwoods database. All the students who have the same classification that Amanda has. So you've got to write a query to get, and classification is like a sophomore, junior, senior. So you've got to write a query that gets Amanda's classification, right? And then you need the main query that pulls what we're looking for, which is first and last name of everybody that has her class. Does anybody want to slow me down right now? So we'll do this in Workbench. Control C, execute it. And I thought I troubleshot all these. Arg. Oh yeah, when you cut and paste, it goofs up the quotes every time. Every time. Gotta go back and fix your quotes. And that cleared up all my squiggly lines. Okay, so there's Amanda and Ruben Sanchez, which we didn't want to include Amanda, but I don't want to get off script here. We could add an additional constraint where the name does not equal Amanda Mobley out here in the main query. But anyway, you get the gist of that, right? So this inner query here, this subquery grabs. Well, let's execute that. Let me get rid of our main query, and we will just use the subquery so that you can see. I hope I'm not getting ahead of myself. I might already have this on my slides. So she's a sophomore. Okay, so this is returning a single value. So we can use the equal sign over here, right? So you got to be aware of what your subquery is likely to return, because if it's multiple values, you need to use in instead of equals. But that's what your subquery returns. So you can kind of see that everything here inside of the parentheses really resolves to be an SO for sophomore. So you could write this main query. It's the exact same thing. I'm grabbing the main query and pasting it in here and saying, and we should get the exact same result. There you go. Amanda Mobley and Ruben Sanchez. So that subquery takes the place of this literal string. And you can do that in any way you can imagine. You can do these main queries and then subqueries. Got some more examples here, I'm pretty sure. Yes. It doesn't return junior, it returns sophomore. Let me fix that. There, fixed for next time. Okay. Yeah, that's remember what it's doing and this rule will be somewhat intuitive to you. Where S class equals, select S class. See that? The same, it's got to be the same field. You, even if you had similar values, similar types of data in two tables, you wouldn't be able to use the equal sign like this because it's looking for the same field. Okay. It's got to go in parentheses. You don't use an order by clause in the subquery. You can still use an order by in the main query, but you don't use it in the subquery. And of course, you've got to have equal or in depending on what you're doing. And like I showed you, writing the subquery, actually working this thing from the inside back out, can actually be a better way to approach this and get it working. Okay. Other rules. Tables used in the subqueries must be included in the main query. And that's starting to get a little more with joins and everything. It gets a little more complex. And yeah, a subquery is part of the main query. It's just part of the where clause. It is getting you either a value or set of values to match a column in your where clause. Okay. Moving on to more. Yeah, and there's single value and multiple values. Yep, we use equal when it's one value, and we use in if it's a set of values, like if it's in a set or in a list. Covered that. Let's write a nested query that displays all the students that were enrolled in the same course sections as Amanda Mobley. So we need a subquery that retrieves the course sections for all of Amanda's courses. So I'm thinking multiple values. I know it's on the solution's on the next slide, but I'm trying to do this without looking at my script. Okay, so let's. I'm going to try this without a script. Let's see here. So we want a subquery. So we will select C sec ID, and this is in the course section table. CSEC ID from course section. Let me see what we got there. Run. So we got 14 different section IDs, 1 through 14. Okay. So we want.
Question.
Ma'am.
Did you use some sort of shortcut to make it run?
I did. If you hold Control and press Enter, it's the same as pressing the lightning bolt, which saves you a little bit of mousing. So Amanda's courses are not in course section. They're in, I think it's in enrollment. I think I'm looking in the wrong table. Yes. So we're looking for CSEC ID from enrollment. Control Enter. So yeah, I think we have multiple, multiple different ones here, but we want to see where student ID equals Amanda, right? So so we're looking for where SID from enrollment. So I'm gonna where SID equals, because I'm going to try and go get Amanda's yeah, I'm going off script here. Yeah, rather than goofing through this, let me cheat and go to my next slide. I think I'm reading too much into it just by looking at it, but it does show you though. So we're getting the section. This is the subquery. So this is, yeah. I was reading too much into it. So here's our subquery. This just gets Amanda's section IDs where Amanda is enrolled. So let's run that. Single quote problems every time. Every time. Okay, so she is enrolled in section 11 and 12. So as we thought, displays in the same course sections as Amanda Mobley. So we're assuming she can be enrolled in more than one section. So even if by chance she was not written in one or not enrolled in more than one, you want to write your query to match the data. So she is enrolled in more than one. And that query got us that. And then the main query are the students where the student ID in the main student table equals the student ID in the enrollment table that we were just looking at, where from the looking at Amanda Mobley's sections, and CSEC ID in this list of CSEC IDs that we got from the subquery. So I think I have the whole thing in here, but I'm going to try and make it work before your very eyes. Okay, so there's our main query. So now we got to edit our subquery. We got to add our parens, but everything else, I'm tabbing it in because I'm OCD, and that's just the way it works. Okay, so our single quotes are still good. But I got an error. I forgot my close paren. You have to close the subquery and close the subquery in parens because it is returning a value. Everything within those parentheses is returning a value or values that will be evaluated by the main query. So this should get us everybody that's enrolled in section 11 and 12. Let's see if I got it right here. There we go. And it's multiple times that Amanda and Michael Connolly say are in the same section. So you get the union of all occurrences as opposed to a distinct list. Everybody seeing that one? Any questions on how that query came up with that? This is getting complex because we're joining two tables that are related, right? Because the student table has a one-to-many relationship with enrollment. Students can be enrolled in many sections.
This is where those diagrams I think are helpful, because it's helpful to see like where the records are, like which tables they're in and which ones you want or are interested in.
I
Like, it's
agree.
tough to do.
Laura, I agree. And that is in, right, my ERD. Yep, there it is. It's always helpful to have your ERD open when you're doing these sorts of things, especially until when you're not super familiar with the data. But here's what we're talking about. A student can have multiple enrollment records. They can be enrolled in multiple sections. And the way we keep that separate is we keep the student ID and the section, the course section, in this enrollment table. That enrollment table is the link between these course sections of, you could have 10 sections of Biology 101. Each of them will have a unique section ID. So this enrollment table is how you link one student to his place in or her place in a course section. So yeah, having the ERD definitely shows that relationship and how you link. A simpler join, and I will come up with these using the W3 Schools Northwind database. A simpler join is to go get related data like this term only connects to one table. It only connects to to a course section using this term ID, and then it describes that term, spring of 2020, whether it's open or closed. You could have other information about a term, but it's only linking back to this one table, really. I mean, you can do convoluted joins. I don't know that we'll necessarily get there, but there's virtually nothing that you couldn't ask and answer from this table. Like, what terms have the most students enrolled? I'd have to think about that. I just made that up. I would have to really think about that and how I would answer that. But that's a typical thing where you've got to go grab, all the students that are enrolled in a certain course section in a given term. So you've got, kind of a complex join between those three tables, or I'm sorry, four tables, and then some fairly complex constraints in the where clause. But you can answer those questions. But that's why SQL developers get paid what they get paid. It's complex. Okay, I don't have enough screen real estate. But you are very correct in pointing that out, Laura. The ERD is your friend. If you can, when you're doing these, uh, um, I don't have an ERD for the Northwind, but the one I posted up there is really close, and it's useful. If you print that out, it might help you get through some exercises using the Northwind database in W3 Schools. Okay, back to where we were now. Okay, some notes here. Subquery provides all the course section IDs. Yes. Multiple, that's why we use the in. Note the result lists duplicate students. Yes, we got Michael Connolly in there twice and Amanda Mobley in there twice. To delete the duplicate names, add distinct to the main query. So we will add distinct up here. And it gets rid of our our weirdness from the multiple entries in course and section and enrollment and students and whatnot, and deletes any duplicate. It'll eliminate duplicate individual rows like we did select distinct shipper or whatever it was in the other database, but it'll also eliminate duplicate combination rows. So there you go. Like you would think, like you would want most of the time. Sometimes you don't want to use the distinct if you're going to be putting it in a pivot table. Okay, subqueries that return, yes, have used the in. So you got to be ready for what your subquery might return.
Do you,
Use it.
do you
Try.
have to use an in even if it's numeric? Like, can you do booleans like greater than or?
Well, if it let me try and think of how we would do that, Laura. What's if it's returning a numeric value, you still use in because CSEC ID is a numeric field. It's an integer. So you still say in. Is that what you're asking?
Yeah.
Yeah, you say in because it's multiple values. Let's see what happens if we, well, you can't say greater. You can't use a mathematical operator if it's more than one value. Like if the CSEC ID is integer, but I couldn't say in the for the subquery here, I couldn't say where CSEC ID is greater than that than this because it returns multiple values. And it
Got
doesn't know which one, yeah, it doesn't know which one, which value. So I think it would error on syntax as much as opposed to during execution, which is it's impossible to tell.
But in your subquery, you could filter to like only values greater than a certain number and then answer your question. I'm thinking of how to answer the question that's on this slide.
Oh, cool. Well, let's talk through that. Okay. Because I mean the answer's on the next slide, but let's try it. Use a nested query to display the course name, which is course ID, and capacity for all courses that are taught in a room where the capacity is greater than 40. Yeah, this would take me probably 4 or 5 or 10 minutes to crank through. But the first thing we would want to do is clear out our old query. So we want, is it location tables that has capacity? Yes. So we would select, we've got a subquery here where we're going to, this is going to take me too much time. I've got it built on the slide here, but we're going to have a subquery that pulls room from location where capacity is greater than 40, right? So we'll have a subquery that gets us that. So we'll have a list of rooms. To display the course name and capacity. Yeah, I'd have to crank on this for a minute, and I've got it in the can, so I'm going to cheat again. Okay? Or do you want to, Laura? Do you want to work through it, or
We can cheat.
say that again?
I said we can cheat.
We can cheat. Yeah.
Yeah.
Because I mean, I enjoy doing that, but it's a waste of your time watching me. So yeah, here we said, yeah, we got a subquery where we're gonna grab the capacity that's greater than the. So this is an interesting thing that we haven't done yet. So we're looking for a list of capacities, not a list of rooms. I misspoke. We're looking for a list of capacities where the capacity is greater than 40, which is an interesting premise. So we'll execute that. So we have 3 capacities values inside of location that are greater than 40. Okay, so that's one element of the subquery. And this is where we link the, and it knows capacity is coming from a location. You can, if you're using multiple tables in a from, if you're selecting like this, you can put the table name so that you know by looking at this thing which table capacity comes from. SQL will figure it out. If capacity is only in location and it's not in course section, you don't need to say location.capacity, but it can make it more readable. So you guys kind of got to decide. So here, this subquery gets us our list that we saw before of 150, 42, and 55. So we are joining course section and location because a course section can only be in one location, but a location can have many course sections at different times, of course. Yeah. So that's your join. And when we enter that, any quotes to fix? Nope. There you go. So your course ID, but we wanted course name, didn't we? So what we just got is the course ID. Yeah, they gave us an out. This would make an even more, where was the, here you go. Select the course name. See, what would make this even more complex is if we were to go to the courses table and get the course underscore name. I want to try it. Course ID, comma, course name and capacity. Course ID. So we want course section dot course ID because it's in more than one table. From course section, location, and course. And we want in our another join here because we got to join course dot course ID, course underscore ID. Equals course section, right? No, enrollment. No, course section. Course ID. And this may blow up in my face, but I got to try it. Unknown column.
You've got an extra underscore in your and argument, your first and argument.
Ah, I sure do. Woo-hoo! Look at that. So that's joining 3 tables to get what you really want. What you really want to know is the intro to info systems, I can stick 150 people in there. Sorry, guys. I'm really happy that that didn't just blow up in my face. Okay, so that, yeah, subqueries and joins, and they get, I mean, that's not in the scale of SQL. I mean, you can make a career out of this language. It's a big deal. So let's keep going. Um,
So I wrote along with you in all lowercase and everything works.
yeah, you don't have to put, SQL is not case sensitive, but
Mhm.
the database objects are. So
Okay.
if I put like capital C capacity here, let's see what happens. Did it just made a liar out of me?
I think it depends what program you're using. Like
It
some require it and some.
It might, because it barfs in that W3 Schools engine. But for some reason, it's allowing me to do that here. Don't you just love consistency between environments like that? So yeah, you don't have to put SQL statements in uppercase, but for readability's sake, that's kind of the convention. That's kind of how folks do it.
Makes sense.
And it's the same with putting um, your different clauses, your select, your from, your where, and indenting a subquery. That's all just kind of standard readability sake, but it
Okay.
doesn't have to be that way. All right. So where did we get here? Oh yeah, all of that uh, was kind of programming your way into more difficulty than it needed to be. This on slide 18, you've got a simplified version of that. So it's kind of like wah wah wah, and you can find yourself doing that. You can find yourself overthinking something, and there's a more elegant way of doing it. Um, so this compound where clause does the same thing as this uh, kind of convoluted subquery. Okay, keep on moving here. You could specify multiple subqueries within a single nested query. Yeah, and use and or to join them to use more than one. Suppose you wish to retrieve the names of all students who have the same S class, which we know is SO, not JR, as Amanda, and have also been enrolled in a course section with her. Well, that sounds complicated. So here it is. So here's just showing you that you, depending on what you're doing, you can have um, more than one subquery. But you notice here we got an equal sign, so that we are sure, based on the data model, that uh, Amanda can only have one S class, and we know that because it's a column in the student table. It can't return more than one S class based on our database. You know what I mean? Based on our data model. So of course that's going to be an equal sign. But we know that students can be enrolled in many sections, so we'll always want to use the in for this one. Okay, so if we plug all that in, and it came across with the right quotes that time, it looks like. Yeah, we're back to Mobley and Sanchez. So yeah, multiple subqueries, and you can do a subquery within a subquery. I mean, it's like nesting loops within loops and if then else's within if then else's. If there's a limit, I don't know what it is. They get pretty hairy. Okay, one last query. This one will display the student first and last name, the grade, and the advisor last name for those that have the same advisor as Daniel Black or have made the same grades as Daniel Black. Yeah, I want to say I got a certain distance with this one and couldn't get it to work. Let's see what I get here. I can't get this to work as advertised, but I think I got some of the segments going here. So here's a nice simple query that gives us Daniel's grades, but this is a good example of joining two tables, right? We plug that one in. So all we're going to display is grade. But we've got to tell, since we're using Daniel Black, which is in the student table, we've got to join the student table and the enrollment table. The grade's over here in enrollment, but we're giving constraints in our where clause that are coming from the student table in the form of his name. So that's why that's got to be joined. The student table and the enrollment table have to be joined. Control Enter. So we see that he gets a C. That's the only grade he has. And next, we create a query that tells who the advisor is for Daniel Black. So we're selecting the faculty ID from faculty, since we're constraining by Daniel Black, we got to grab that out of the student table. And so you have to have the join of the student table faculty ID, which is the column that says who his advisor is. Are you tracking that? So this is another part of that query, another sub-component. And of course, goofed up my quotes. Just one of them, though. Okay, so he is advised by faculty ID 1. And we don't have the name of faculty ID 1 yet, which was another one of our things, right? Don't we want? Yes, we're selecting advisor last name. So now we're going to have to go build that part. Now that we have the two queries, let's put them together and add the main query, which is the main queries we're going to add like faculty last name. Okay. So I grab all of this. So again, I don't like writing queries this way. When I'm pulling stuff from multiple tables, for readability's sake, I like using the table dot column name. So I know like F last is coming from faculty. Sometimes some databases will use a naming convention, like you would call every column in the faculty table faculty underscore something, faculty underscore last, faculty underscore first, faculty underscore phone, so that when you're using it, you know where it came from. When you're using that column, the table name is inherent in the column name. Or you could say, I don't believe there's any error in doing that. You don't have to, because F underscore last is only in the faculty table, but it makes it more readable. So I'm going to cut and paste all of this. So we're grabbing the student's S underscore, student first and last name, and the grade they made from enrollment, and the faculty member that they made in that class, in that course section. Whew. So that's getting to be pretty hairy. Nothing like this will be on the test, the graduation test. Sure you guys are happy about that. So we got to go in and fix our quotes. And notice we can do ands. And this stuff, I mean, it looks complex when you do a subquery, but remember, this stuff resolves to being a single value. It's so if you think of it that way, it kind of lets you sort of insulate the complexity, kind of do it layer at a time, one thing at a time, and doing these subqueries first is the best way to go at it. And then we've got an or grade in, so we know we're possibly selecting more than one grade for Daniel Black, but we tested this and it's only a C. But structurally, you could get more than one grade. So right now, there's only one C, but you would never structure your query or anything else to assume that there will always only be one C, because the database design allows him to have more than one grade. So let's see what we got here. Okay, so we get all of these duplicate roles. We get for every grade Sarah Miller has, we get her faculty member, her faculty. So that's what we asked for. That's the query we wrote. But what they're trying to get this to do on this last slide is to add, if you look at the difference between the queries, you'll see one extra parenthesis down here and one extra parenthesis before this before this query. So it's getting rid of the many-to-many Cartesian join that we have over here, where we have every occurrence of every grade and person and advisor, but I can't get it to work. So see, there's only two little changes there, two little parentheses, but I can't get it to work the way Jim Downey did, and it's pretty advanced. So I didn't mess with it. But if any of you rock stars care to want to make this, figure out why this should make less rows, that would be a good exercise. I could not get it to work. I don't know if it's an error in logic or what. I need to cut this and send it to Jim and ask him. Okay. So that is subqueries. Like I said, it's you don't have to do a subquery. You don't have to do a join. You can do a single table subquery, which I wanted to show you what I'm talking about here. So let me go fly without a script here. Go back to W3 schools. So, like I said, sometimes you want to select everything that's greater, the value of everything that's greater than the average of something. And the mathematical, is it average or is it mean? SQL functions. I always got to look this stuff up. SQL functions for numeric. Mean and max mod. Average AVG. Okay, here's an example. And I'll bring it up in its own thing. So this is canned. This came from the tutorial here. So this query right here is selecting a single value, right? The average price of everything in the price table. But to avoid confusion, let's just run. It makes and it uses the function as the column name. All right, so if I wanted a list of the products whose price is above average, that's my subquery. That gives me my average price, right, for my where clause. So I would, if I wanted to select all the products, and let's make it meaningful. So we'll select product name. What products table? Product name. Yep. Okay, select product name from products where
That much is
I'm sorry?
fun. I mean, maybe other manufacturers making the same brand names, and so it just goes.
I don't know why we keep taking private label as potentials. I had Eric
Hey,
brought
Laura.
me to like one of my first insights calls with
Can you
a
mute
guy
your
I know
mic,
from the
Laura?
neighborhood who sells private label frozen fish, and like
Yeah.
right off the bat, it was very clear that like if you boost.
There we go. Thanks. Private labels, if you boost, boy, that is some wicked jargon there. Okay, so we're selecting product name from products. Where was I? Where price is greater than and then we have our subquery. So I want to tab that in. So and we need a close parenthesis for that. Does that look right to everybody? I'm selecting all the products where price is greater than the average price. What do you think?
Worth a shot.
Look right? Okay, so we found out that the average price was what, $28? So let's show the price and kind of so that we kind of prove to ourselves. So yeah, everything here is over that average of $28. And if we reverse the make it less than now all of these will disappear and we'll get 52 records. Now we got all the under average price stuff. So I want go ahead.
Do you need to have that subquery? What if you just did price greater than average price?
Let's see. That I may be overthinking it. I've seen this as an example in my self-study refreshing where price is less than average of price. That may work. Nope. Invalid use of a group function.
What does that mean?
Well, it means average is expecting a multiple to be fed multiple items. And when you use it standalone like this, it doesn't know to go out and do select price from products. You know what I
Okay.
mean? It doesn't know to go and recurse through the database. It just doesn't work
Mhm.
that way.
Okay, just curious.
There you go. I mean, great question. And you probably more than one SQL programmer is like, why doesn't this work? Because it should. I mean, linguistically. But if you once you start learning how SQL operates and the way it does the loop for you, and it's always going to loop through the database. So you kind of you with this select and the from or and the where and all that, you're kind of controlling how it automatically loops through the database and what it does with each record that it's returning. So that's a subquery. Let's see if yeah, that's a subquery, a single table subquery. So you could also get the product and the price and name where well, like we did before, where product name in now I wonder why this wouldn't work. Let's use single quotes just in case. I'm like I said, this is unscripted. I'm just yeah. Why isn't that working? It needs a subquery. That's what I was thinking intuitively. This needed to be in a subquery. Oh, it's like you don't use in. Never mind. Yeah, I'm trying to think of what would need a subquery. This wildcard, for something like like that, give me all the give me everything that has the word logger in it. You don't need a subquery for that. That's what wildcards are good for. They will almost act like a subquery. Anyway, I can't think of another good single table subquery example. All right. Well, guys, I don't want to go any further, but I hate to end. Would you guys use some time playing around in this W3 schools? Everybody say yes.
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 One thing that, like I said, that it's not perfect, but man, there's nothing like failure to get things solid in your head. If you pull down that ERD I posted, Northwind database query exercises, that has the ERD and some brain teasers. Some of them will not work because we have a small subset, both tables and columns, of the database that this one uses. This one is in Access. If you've got Access and you want to play around using that venue, I think it's pretty accurate. But pull that down and if there are other things in this W3 schools, like I said, you saw me click on MySQL functions, and it brings up all these things in the. Click on each of them. I mean, I went through this entire list a few mornings ago. You can concatenate strings. You can get the length of a string in order to use that as a constraint for something else. There's just concatenating strings. You can change everything to lowercase. You can change everything to uppercase. You can pad a string with asterisks or whatever if you need to. There's all these different functions that you can do with strings, which is strings of characters. And then there's again all the mathematical operators. So yeah, take some time. If you didn't get all 5 of my exercises and you want to try them again from a clean slate, do that. But spend some time with a SQL, and we'll do a refresher on multi-table queries and joins and subqueries on Tuesday. And and I want to make sure everybody's solid with pivot tables. So I'll cover that too. And then we need to get back into Python. Got a couple more Python notebooks to go over. Does anybody not have Anaconda working? Please come off mute and tell me I cannot use Anaconda Python anymore, or I can't use it. I thought somebody was telling me. Lindsay, was that you that it broke Python, or it broke workbook? I mean, Workbench.
I don't know, but it seems to be fixed now, so I'm not thinking about it too much.
Okay. Well, if for some reason ever Python stops working in Anaconda for you, or you're on a computer where it doesn't work, you click on this Python link in W3 Schools, and then click on Try It Yourself. And I want to say everything that we're doing, there may be some really obscure libraries that you can't import, but everything we are doing works in this W3 School Python environment. It's not necessarily as powerful as a Jupyter notebook, and certainly not as powerful as an integrated development environment, but it will let you run Python code, because I need to see that you guys are picking up on Python and able to at least take a shot at some of these programming challenges starting in the next few weeks. But yeah, for the rest of the time, you got what, 40, 50 minutes. Goof around with SQL and nothing like, practice. So think of joins that you might want to do, or think of where clauses. I'll be on my phone. Chase has taken advantage of the opportunity a couple times, and I love it. Call me, text me, if you want me to jump back on my computer and take a look at something with you in real time. Otherwise, I'll see you Tuesday morning. Any questions, concerns for me? Going once, twice. Okay, guys. I will see you Tuesday morning at 8:30.
Have a good day.
Have a good
All
one,
right.
guys.
Bye, guys.
Bye.